Imagine a residential tower along the coast with perfectly optimized shape for apartment to capture ocean view. In this video, I'll show you how to build and use an algorithm to optimize the tower orientation for the best real estate value on that site. Plus, we'll dive into how we could use an AI workflow to visualize potential outcomes. Let's get started. Alright, so the first things first is to have a 3D. So here I got a basic 3D about Broad Beach here. So I just, you just need sort of a basic 3D of the city. You can get them for free, like online on some website. I'll put the link in the description where you can download some of the 3D model for Rhino. So I got basically my Rhino model. I got the context. I got the tower footprint, which is basically this one here. Here we go. So I got this one here, which is basically my tower footprint. I'll change the layer just for this purpose. And then I also have the ocean surface. So ocean surface is basically, I simplify it to this. And the goal of what we're going to do today is we're going to optimize the tower to see how we can maximize the view towards the ocean. So it's something really big on the coast, and it's always something that comes over and over, and there's ways to automate that process using computational design and an evolutionary solver. So with no further ado, let's jump in. So the first things I want to do is I'll set and use this footprint and put it on the floor. So here I'm setting points to get it flat on the floor. And this is basically what the script's gonna look like. So if you're a Patreon member, you're gonna have access to that script and also all the files. So so the first step we want to do is we want to set that curve. So very simple. We're just gonna set the curve. Set one curve. Then after that, we're just gonna move that curve. We just want to move it up. But this time we're gonna move it, but we're gonna give it a rule to move it. So that will be our slab. Okay, so to move it in the Z direction by to describe the lot of floor, what we're gonna do is we're gonna use Z to give us the direction of the move, but we're also gonna use Siri. So I don't know if you're familiar with Siri. Siri is a brilliant tool that will sort of help us define a value. So if I go here outside my Siri, I got 0, 1, 2, 3, 4, 5, 6, 7 all the way till 9, and I am in meta. So basically I have a line every meta from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But a building, obviously the distance between the slabs can't be 1 meter, so we're gonna define that distance, and we're just gonna say 3 meter be our floor to floor, and I'm just gonna put it here. So now we have 0, 3, 6, 9, 12, 15, so it's just 0, 3, so we have a slab every 3 meters. So, and then we're gonna call this one, instead of number slider, we're gonna call this one floor to floor. Okay, and then maybe we're just gonna say meta, so it just help us to define. And then the number of floors. So what we're gonna do is here we're just gonna do, for example, 60, and that will be our number of floors. So you can see here by default I have the count is 10, so 0 to 9, so we've got 10 value. Now we see here we've got 10 floors, so what we want is just changing the count to whatever it needs to be. So now I got 60 floors, but I can reduce it to, I don't know, 30, 40 floors. I can increase my floor to floor I can also change this slider to edit it and have a bit more play here with the floor to floor height, and then the number of floor. Okay, so this sort of gives you a good start of how the building, how the tower looks like already. And then we can call this sort of slab. So here I can do curve. What I'm gonna do is I'm just gonna do a boundary surface to have a geometry, and there we go. We have already like a surface for a slab. So what we can do here is we could actually extrude it. Extrude our slab. And I like to extrude it in the Z direction. So the way you can use it, you can use a vector amplitude. And we're just gonna plug our vector here, and then the amplitude we're gonna say 0.2 for now as a slab thickness. And then the vector, we're just gonna say Z vector. But I always like to keep the surface at the top. So then if you need to increase the slab, it will not sort of, I don't know, reduce the area here and make it very confusing. So I like the slab to be towards the bottom, so underneath, and we have that surface always at the top. Helps with apartment. If you deal with apartments, if you start populating those area to put it eventually to Rhino inside or those type of things, it helps to have it as the top floor. So here we're gonna do negative, and negative will actually help us to go through and put it towards the bottom. Okay, and now you've got the tower here. Okay, so that's sort of how you can get your slab. Now another things that you can so here I can do VRAP, and those are right click slabs. So I can right click on the component, change it here, and it changed to the text I type here. So sometimes it helps to sort of read it a bit better. And then what we could do is actually we could measure the area as well. That's also always helpful to get the area when we have a tower. So what we're gonna do is we're gonna measure the area, and then if I take a panels and I select the area, you can see there's a lot of 0 here. We still don't really know how big the tower exactly is gonna be, so you know it's always good to round that. So there's different way to round it. This is a bit of an old school way to round it, but what you could do is you could actually divide. So you do a division of the area, simple math, by 10, and now I'm gonna have that results. Okay, 70. And what I do is here I round it to the nearest. So now I get 71, and then I multiply again by the same value. And so by doing so, I actually I round it to the 10. So if you look at what we had before, we had 705, very close to 710 per floor, square meter per floor. And here, if I do 10, I can also round it to 2 decimal, and then I can get here, and I can get here my 700. So that could be also a way, if you feel like, you know, you're not that close to, you know, 710 is quite close to 7. Let's round it to 7, because you know by the time you add the chords and everything. So we can do this, and we can round it here to 100, and we'll roughly have 700 square meter per floor. Now there's one thing that I can do here is I can do a mass addition, and I can addition all those results here. And then by doing so, I have my total floor area, and I can just do here. The problem with this one here though is it's measuring, of course, from 0, so from this one 700, but it also calculate and measure the roof here. So we want to remove the roof. So one way to remove the roof is we can just remove one of the units, or if you want to make it like really perfect and remove exactly the roof, we can do reverse list. And reverse list will sort of flip your list, and then the roof will become the item 1. So if I select item 0, here is when you reverse the list, that's item index 0. So it's the roof slab, but if I put this one, it's gonna be the bottom one. Okay, so basically what we can do is we reverse the list, and then we're gonna call. And we're gonna call index, and we're gonna call within this 0, and this is what we have now, and that's what we want to. So you could, you know, eventually if you're concerned about the order, we can put it back in to our list, and then there we go. And now you can see that the area here is, it calculates the area only where the points are, and that gives you a good idea of how it looks like. So that's how you build a tower. And you can also extract the number of floors. So if I go and I push this one here and I extract the number of floor, so now that I have this one, all what I want is the length of my list. So list length, and then I can open and get the panel. So here I just double slash to open a panel, or I can double click and do panel. Okay, and that's how you basically have your number of floor. So here I can right click here on the panel, and then I can call it number of floors. And here we're just gonna do, say, call it total area, gross area. We can call it total gross area, and there we go. And we have now our tower, and then the slab here. And another things we could do, and we can add to this process, is actually having some sort of facade we can use. So how do we do that? Probably the most simple way to do it is to actually use those lines to create a facade. So I can do a facade from there to there, and then there to there, and then there to there. So let's do a very simple facade, and we're just gonna loft our facade. So I'm just gonna do an item list, and I'm gonna select my first one here, and then I'm just gonna reverse my list, and this will generate sort of a roughly facade from all the way from there all the way to the top. But we can also take each of them individually. I'll show you. There's two options you can do that. So here the first option is to do it the full one. So we take the bottom one, the top one, and then I like to put it back into order, and then we can merge, and we merge the top one and the bottom one, and then we loft. Okay, and now I got my tower. So that's one way to do it. Another way you could do it is you could do it floor to floor, as I explained before. To do that, you want to again have a series. So you want to have a series, and what I like to do is I like to do 2 series in a row. So it's very old school. I'm sure there are plugins now, but that's how I've done it in the first place, because when I learned Grasshopper, it was in 2011, and it's always a good way to do it. So here, what I need to do is, instead of 2, I need to do I need to select here my 2, and then here the list length. So I'm just going to explain you what I'm doing now. Okay, so what I've done here is, here I got a list of 38 floor, okay? And what I say is I want actually 38 lists or path within that, out of this series. So I want 38 path, and so the way I do it, I plug it to my series, and then here I have the count. So from 0 all the way to 1, so from 0 every 1, sorry, and then it's with a count of 38, and then out of this series I have basically 38 values. By putting those values into start, I'm creating a branch, a new branch for each of those values, and then I do a step of 1, so which means, and the count of 2, so they're gonna be 2 values in each branch, and that will allow me to loft each of them individually. So the reason I could do that, I'll show you later. But what I can do here now is I can do an item list, and then I can loft and bring those lines. And now those lines are organized. There's 2 polylines per branch, okay? And I can loft them. If I loft them, I'll have 1 facade, 2 facade, 3 facade, etc., etc. So now let's have a look at it, and just to double check, I'm just gonna bake it and make sure I got it right. So I'm gonna right click in the middle, bake it, and there we go. So here you can see that now the facade are going from the top of the slab to the top of the slab. Okay, so and then if I select and delete all that, and if I bake this one will do something very different. It will go, see, 1 element, and it will go from top to bottom. Now the difference between the two is that here I have 38 individual values, whereas here I have only 1 surface. What happened is, if you brep deconstruct, deconstruct this one and you select the faces, let's say item, and we're going to select 1 faces. So if I select, I can actually select all the faces, that's okay. And then here I have 4 faces. Now if I use Lunchbox, as we used in one of the previous video when I was Lunchbox, so if I go here under Lunchbox, and let's do, I don't know, those ones. So here, if I turn off this, here I have the diamonds. So the diamonds are gonna be subdivided, as you can see, on the full facade. So that could be quite nice. Just reminds me a bit of the Gauguin from Norman Foster, but in a rectangular sort of shape and form. So that could be your main structure with this amount of subdivision, and then you can have it, you know, obviously different faces, different subdivision. Now if I copy this and I put it on this one, it's gonna give me something very different. Okay, so here we can see, actually, I think there is some issue here. But actually here you can see that the subdivision happens always for each of those faces in there. So it looks like there's just one thing that I should have done. Here we go. So there is here, I think it's the last one. So I think I need to do length 38 because there's 38. So I think I need to do right click here, count, and then I need to do -1, I believe. So I shouldn't have done that. X -1. And now, there we go. Now it works. So what I've done here is I have 38 slabs, and what happened with this series when I do this is it actually, the last list, if I don't do this -1, the last list will go from the top of the roof all the way back to the 0, and that will be a branch here. So by doing this, I remove the last branch, which goes from the roof all the way to the bottom, because I don't want that. It's basically what this here is doing, and it just sort of doesn't work as well. So you can see the difference between here if I use that type of geometry versus that type of geometry. So that's quite important when you deal with paneling and facades and things like that. So I'm just going to go back into the wireframe. Okay. And so here that could be Vera, and that would be our full facade, and then we're just gonna call this one split facade. All right, so now that we have our slab, our facade, so now what we're gonna do here is we actually, I'm just gonna bring that back here, make it a bit neater. Okay, so now that we have our script here, what we're gonna do here is we are going to have a look at the next step. So the next step is we're gonna extract this surface here. So I'm just gonna grab the surface. And what we're gonna do is we are going to analyze. What I'm gonna do is I'm just gonna do surface, new component, and here I'm gonna call it slabs. But those ones, remember, it's just, I just want one surface. The reason I just want one surface because I don't want to deal with too much geometry. So we're gonna minimize the amount of computing power needed. So I'm just gonna grab one slab, like the slab, simple surface, and then I'm going here. So I'm happy with this. Just gonna select this one, make it default. Okay, I'm happy with this group. I have good understanding of this, so I can start from scratch, sorry, with the slabs. So the what we're gonna do here is we're actually gonna move those slabs. So we're gonna move them around the side. So let's say we can move this tower around. We have like a site, define larger plot, but we're not too sure yet where we could put the tower, again, to maximize the amount of visibility towards the ocean. So what we're gonna do is we're gonna give it a serial full. So we're just gonna do items. So I'm just gonna select one slab. Okay, so I'm just gonna select this one. The reason I don't select the Rhino is because I need something flexible that I can move. So I'm just gonna select this one and I'm gonna explode it. And then I extract just the segments, and then I'll just item, and then I'm just gonna move one of this. So I'm just gonna move the tower out. Let's say I can move this tower. Let's say I can, my site here would be, for example, from there to there. Maybe there, and then of course you need to define it before. This is really rough estimate of how the site could be. So what we're gonna do is we're gonna tell it that it can actually move the tower all the way in this space, and we also, just for this purpose of this exercise, we also allowed it to rotate around there. That might be like a tricky solution, so but we'll figure it out later, but we will let it rotate as well. So what we're going to do here is we are going to select the end point and the start point of that edge. So you remember I extract that edge here from my rectangle, and then I item it and index 0, so this one, and I'm just going to extract the vector. So I'm going to do vector 2 points. By doing vector 2 points, I can actually extract the direction, and then I'm just going to move that, and then I'll just use vector amplitude. Vector, and then here I'm just going to give it an amplitude. So let's say 40 meter. And I'm gonna move this. So what I'm gonna do here is I'm not gonna move this, but I'm gonna move all this with this amplitude. Now it's moving in the wrong direction. So what I'm gonna do here is I can do negative. We see a bit better what's happening. Alternatively, you can right click here and you can do expression, and you can do x minus 1. And this will go in the other direction. X minus 1 or negative here. Okay. Alright, so now here I can move, so I said like I can move my tower here, and then 50 is the maximum. So I'm gonna edit here, and I'm gonna change this to 50. Okay, and then I'm also gonna allow it to move by, you can also move this one, so I'll copy paste, and I'm just gonna do the same here. I'm just gonna copy paste this. Okay, and I'm just gonna item again, but this time I'm just gonna select, instead of the number 0, I'm gonna select the edge number 1. So the edge number 1 here, so select 1, it will be in this direction, and then the vector 2 point will be in this direction, and then I move it in this direction. Now same, I'm just gonna push it to the edge here, and I'm gonna edit my slider. It's important to edit your slider. Let's say 30 meter, and you will see why later on. So now I got my 2 translation. So basically, if I hide everything here, I have my tower, and then my tower can go here, but it can also go here, and it can also go here, and it can go here. Okay, and then we can go here as well. And what we're gonna do as well is we're gonna allow it to rotate. Okay, so the way you can rotate it is rotate. So now we're basically setting up, I'm just gonna use the other rotate. Rotate around plane, and then basically what we allow, like we're setting up now, are the parameters, what we can test, what are we allowed to do on the side. And here I'm just gonna create I'm gonna explode this one again. This geometry, I'm gonna explode it. This geometry, and then I'm just gonna say vertices, and then I could select item. So I'll show you something. I could, like here, I choose one point, and I can just use it as a rotation plan. So you can see rotate around this plane, or I could also do, which I prefer because of what we're gonna do later. I can just use a centroid and it will rotate based on its center. Okay, so this is sort of, and now we're gonna define the angle. Here, if I right click on this, by default they are all in radian, the rotation. So I just right click here and then I put it in degrees. That's quite important, otherwise can be very confusing, but basically here we can rotate our tower as much as we want. And what we're gonna do here is we actually even gonna do, so we could actually start with a very simple one where we just rotate it here, and I show you later what we could do something a bit more impressive. So here is your rotation. So we could do this as a rotation, very simple rotation. Another things we could do is actually the number of slab here. So if I do list length, to extract the number of slab I have in my tower. So I got 38 slabs, and I can actually do a series again, and I'm just gonna count them. So now I got 37 value. And I'm just gonna use remap again. So if you follow my video, I use a lot remap, love remap. And here I'm just gonna use the bound. And the bound will basically allow me to get the min and the max, so 0 and 37. And then I create domain, construct domain, construct domain, and here that's where I can set up my angle. So here I could say 360, right click, I edit it, and here I'm just going to change my max to 360. Okay, and then I'm just going to copy paste this and I'll put that in there. Okay, so now I can just change that and I have my remap here. Now, instead of the simple angle here, now my remap is remapping 38 values between 65 degree and 360 degrees. So this is how it looks like. So I'm just gonna hide everything else, so we have a bit of more of a vision of what's happening here. So there we go. So now I have basically, instead of having a constant rotation, I can have a rotation from, you know, whatever here. Could start there, and then I could finish here. And basically what we're going to do is we're going to ask the evolutionary solver to tell us what's the optimal things here to do. Okay, so we're just going to skip that simple rotation and we're going to ask it, okay, what's the best for that? So the way you do that here is basically we have all our surface, and that's where you need to use Ladybug. Okay, so Ladybug will help us to define those view towards the ocean. Remember, this is my ocean. Very simple plan. I draw in Rhino, and we're gonna go to Ladybug. I'm gonna do a tutorial a bit later to explain how to install Ladybug. But there are plenty of video out there to explain exactly the step by step. It's a bit tricky sometimes, so So I'll show you here. And what we want from Ladybug is the visibility. The visibility percent is what we're gonna use for our ocean view. And we're also gonna use generate point grid. So basically, and then here we're gonna use a surface, and that will be set a surface, and that's our ocean. So I'm just gonna set it up here, and I'm just gonna call it ocean surface. And then my grid size, I'll set it up as 100. Let's see, 200. 200 should be okay. So basically the grid side, the more point you have, the more accurate that might be, but also the more time it's gonna need to process. And this component, as you can see, is already like, I drop it in and it already takes, like, it's already quite heavy in terms of computing power. So we're gonna keep it like this. And then the offset distance, by default it's 0 number for the distance to move the point from the surface. Okay, so we can move this one by 0.2, so that might help with the calculation. So that lift the point slightly off the surface. And then what we're gonna do is we're gonna use this point as viewpoint. So basically we're gonna ask each of those floors to see if they can see any of those points and how many of them, and then give me a percentage. And then what we're gonna do is our surface. So our geometry here is basically this ones. So it's the tower. So we're gonna plug the tower here, and then we're gonna do B-rep, and we're gonna select our context. I'm just gonna go here, right click, select, right click, set B-rep, and that's our context. So something to get used to is renaming your layer the same way in Grasshopper and in Rhino. It just helps a lot down the track when you open it again. And then the grid size. So the grid size, it's a bit of a tricky one. Again, same idea. The smaller it's gonna be, the more computing power it's gonna need. Okay, so here my tower here is 15 meter wide. So it's just a double loaded corridor. You get a corridor in the middle, and you get like 1 unit on one side, 7, and then like 6, yeah. And then it could be like sort of 15. We could push it to 17 meter, but so I'm just gonna keep it 15 meter wide, and then I'm just gonna keep my grid side as a 15. If I decrease that, it's gonna be smaller. So it means like, what that does, the grid size, it subdivides that surface by the grid you've got. This is also very important, especially when you work with Ladybug and Honeybee, is to make sure your units here are matching those ones. Otherwise your computer will freak out. And then a boolean, and then here we can just set it as run. And what we want here is we want the data. So I'm just going to do data. So I want the results, and I also want the mesh. Okay, so the mesh will help me to visualize it. Data will just show me this, and the legend here, there will be a legend as well. So I'm just going to hide everything there. And now if I set to true, there we go. So now I got, like, here it's running. So percentage of view. Oh yeah. So here it just doesn't make any sense, because yeah, it just doesn't make any sense. And the reason it doesn't make sense is the offset distance. So just realize that the offset distance can be quite important. So I'm gonna put it at 1.6. So let's say you're standing on those slabs, you see the ocean. So that's the offset. So same as what we have here, 0.2. Just gonna apply that to it, and bam, we've got something very different. So this is quite important. parameters. And you can see here, obviously at the bottom here, we can't see the sea. I'm going here, you can't see the sea at all, can't see the sea at all. And then you only start to see it at 1, 2, 3, 4, 5. 5 you start to see it, but again, quite abstracted by this building. And then the higher you go, the better the view is. But you can see that if I increase this one, so if for example, change this, and suddenly we have a tower here, that might affect the result. So, okay, so this sort of will affect the way each of those ones are done. And then you can reduce that, of course, to something a bit more accurate if you want to. So if you do manual work like this and you change, you move your slider, you know, and you just like look at it and you just okay, what if I move it a bit towards here? And what you could do to help you with the results is you can just mass addition this, and this will give you a number that doesn't really mean much, but basically you want to maximize that number. So if I go back and use this and go back here, and I'll just push it back there, you can see that this number is going down. So not good. Okay, this is worst. And you go here, and this is a bit better. Now I can also do the rotation. Say, well, what if we rotate it a bit more? Nah, that's worst. But this one, yeah, that's worse. So we saw like 17,000 was probably the best. And so basically that's what we're gonna ask Galapagos to do. We're basically gonna ask it to maximize that result. So opening Galapagos, and then I'm just gonna select the thinness, plug it here, which is a bit weird. So this one is just doesn't plug here like this. You have to start from the thinness and you go to your results, and we want to maximize that result. So I'm double click on this. I make sure the thinness here is maximized, and you can also minimize if you know it's another tools and you want to minimize, for example, when you're dealing with radiation. I'm gonna do another tutorial about it, but if you want to minimize the amount of radiation on the facade or inside the building, you might want to minimize that, but for now we want to maximize the ocean view. So maximize, and then we can close it, and now we're gonna look at the genome. So the genome are basically what will influence that result. So that's the moment to reflect on your design and be like, okay, so maybe I'll just do 0 to as a maximum rotation. I think just 0 to, we do 0 to 90 degrees. It's already quite tricky in terms of structure, I guess. So let's say to 90. So I'm just gonna do edit, and I'm just gonna change the slider. So we basically reduce the amount of iteration he needs. So we're just gonna do 0 to 90, and then I think that will be enough. And then same for the genome, you can't plug it here like this. You have to select and select your slider. Okay, so now I got this one, I got this one. I need to press shift. So I got two, so my rotation, but I also want my movement. You remember how we move these things? So same idea, shift again, and then I click on it. And I go back, shift, and I click on it. Okay, and now that we have our genome, well, all what we have to do is double click on this, solver, And then here you can show the iteration, and then we can just start the solver. So you can see the results here already. We have 22,000. So, you know, when we were manually trying to do it, we're like close to 17,000. So it already found a much better result going through that process. And what it does here is just refine the amount of iteration. So you can see that that zone in the middle here is reducing, and then here until it gets sort of closest to that. When I will click on this, it will sort of bring back the data to my slider and will say this is the best option and this is the best result for that specific location with the current context. So here we can see it tries the different options. One thing to be aware is this part here. You can see that this is sort of like where it becomes a bit more challenging, and you may need to refine the script to make sure that you allow that movement, because when it starts rotated, of course it will go outside boundaries you define. So it's just sort of something to tweak a bit to understand and know. You can also like sort of play with the form and the shape of this rectangle. You could scale it, you know, increase the width. Maybe 15 meter is not the right width. You could adjust that. You could increase the length. You could vary those things. Okay, so I think that works quite well. So this is actually what the result came out with. So what's interesting is, you know, it's sort of pushed, of course, here as much as he could, because it's like, if I rotate it, I'm still within these boundaries and I can have that view. So of course, this is very tricky because our side is here. So we might want to sort of like readjust some of the parameters to make sure that our geometry stay within our boundaries. So, but this is sort of an interesting result. So here you can go back and reinitialize. So this will give you this result. You can also go back to this one. So, you know, we could also go down and then go back to like sort of one that was they're all slightly above the beyond this those boundaries, but basically that's sort of what we can do, and we can sort of shift it a bit and change slightly in the parameters. So let's have a look at it in a better way. So if, for example, I have those ones, and if they rotate by 90 degrees, so ideally you want this to be in relation to this one. You want this to be at least, so from there to there we have 23 meters, so you want it to be at least 23. Okay, and then here it can only move we could actually, how much did it, and again, you know, like what's your setback? Well, we can move it back. Let's move it back by, let's say we move it back by 8. Okay, so that could be that could work actually, and then here we roughly have 15 meters. So what you need to do here is, here we can go all the way to there. It's not gonna bother us too much, but here can't really go back more than 18 meters. So I'm just gonna edit this. Instead of 50, it's only gonna be 18 meter. Okay, so now we have something that could work. And of course, I need to rerun the analysis. I'm just gonna go back to this, and I'm going back to that, and then I'm just gonna go back here, maximize solver, and there we go. Okay, so I think that's the result. So we're just gonna stop the solver. Okay, so that's interesting. So very small rotation, not even rotation. So that's very interesting results, just because sometimes, you know, you just wants to do some architecture and you want to have that rotation for the beach view, but based on those constraints here and based on the location and based on everything, the tower is actually better facing it. So it's very interesting. I love designing with data because I think it gives you some really interesting insight, and at the end it's probably way more efficient, more sustainable, less material, less structure, complexity. So it might actually be a very good outcome for the site. So again, you know, it's very interesting to see, you know, that even if you put the rotation, it doesn't mean that he will require to get better results. So here we've got, you know, a perfect rotation. He had the opportunity to rotate. The only rotation is done on the side is just this one here. So you can see slightly rotate to get the maximum view here, and also like to get that here, that views here, I guess. So there is, like, you know, it's a very interesting one. But again, it might have been, you know, wanted to push a bit further here, but it couldn't, because the setup we give it can't really go and be facing this edge here, which that would be quite interesting to see if we move this one. So let's do 21. Okay, and now what we're gonna do is we manually gonna move that tower towards there to see if we can even improve those 21,000. So I think it's this rotation. No, so it was 0. So it's the other one here. Yeah, so it would be, it was at 0. So let's do minus 15 and see what comes out. So if I bring it back here, let's see. Okay, there we go. So we got even the better results because we get even closer. So here we have 21, 676. And if I bring it this one back to what it was before, we had 21. So you see how, like, you could actually, it can really help you to actually refine the result you have. It's not finalized. You can optimize it even further manually. So there we go, that's the result. So we have a slide angle on the side, and then again, you know, I might need to slightly push to fit within the boundaries, and maybe we're gonna need to do this, and you might lose a bit here, but it's still really good. So you can see, yeah, still very, yeah, quite close. Okay, so we've got a good results here. Now what we're gonna do here, now that we have our tower, We have the percentage here. That's all what it does, right? It's just collect the data and then maximize the view. So you get basically almost 100% of ocean view on all those apartments here. And then you have down to 70, 67 in those ones, 58 in those ones. And then when you go towards the back, you know, here there might be some ocean view as well. You can see that my ocean is here, so there might be here. It might pick up here on that corridor, on that view corridor. Yeah, so definitely that's why here it's green, because you can see here where I'm sitting. So yeah, and then those ones are completely obstructed by the tower, which makes sense. But anyway, that's sort of where we got to. And then, but what we're gonna do though is we're just gonna select our geometry. So I'm gonna go back all the way to my geometry, which is this one here. So this is basically the mesh that project the data, and that's my geometry. So I'm just gonna do surface, or I can just select, I might just select the B-rep actually. So I'm gonna select my B-reps. Actually, I'm just gonna need to do surface. Okay, and then we can do, again, we can go back to our slab here where we extruded it. So I could just copy paste this. Control C, Control V. Basically what I've done is I just copy paste again my slabs, where I extrude my surface into slabs. So you can see here I have my slabs. 0.4 is a bit big. 0.3 as well, but keep it 0.3. So this is sort of where I sit now, and then I'm just gonna do the same for the facade. So again, I'm just gonna select my facade, and then for the facade we can potentially, actually we can select the full facade. So I'm just going to select this again, and I'm going to plug it to my, copy that, and here I'm just going to select my surface, explode. Yeah, so I need to join those segments. And I will need to flatten them. So by flatten them, I have all my curve, but then they're all in different lists, and I flatten them because I want to select the bottom and the top, and I want to create a loft out of this one. So now I got my facade, so full facade, and then I could potentially use Lunchbox again, and maybe we can do this one here because it's a nice rectangular. So I'm just gonna explode it. So B-rep deconstruct. And I'm just gonna select my faces. So I have 4 faces. So I'm just gonna put the faces in different order. So what I'm gonna do is I'm just gonna select my faces, and then I'm just gonna merge item. Gonna merge item 1 with item 3. So that would be my small faces, and then my large faces would be those ones. And I'm just not gonna split them the same way. So I'm gonna have this in one size and then this one for the big one. And so by doing this, I could just change a bit of the division. So here I could do 25. So maybe on the big one here, I'm just gonna have a bit more subdivisions. Be quite nice. And then here, if I have the same number of floor, I could actually grab my number of floor. So every time I change my number of floor, it will update. So I got 38 floors. So I could actually grab that slider, plug it here, and now every time I change, I have always a floor to floor. Yeah, I think I need +1. So X. Oh, it's X -1 because it counts the roof. So we need to remove 1. There we go. And now we have a floor to floor. So if I change my number of floor, it will also change that subdivision. Really happy with this. And then for this one, I'm gonna do the same. Maybe here, number of floor. And I'm just gonna select a number so then I don't have to drag stuff around. And that's our number floor. Number floor here, subdivision, now do the same expression. X -1. And then here I'll just keep it lower because our okay, so then we have some nice panel, and what I'm gonna do is just to give it a bit more more depth. I'm just gonna grab the area and I'm just gonna reduce these panels by a factor of 0.98. Slightly smaller. So then we start seeing a gap here in between, and then that will sort of visually help with our AI imagery. So if I turn off that, and I may just skip my slab. Okay. And then here we are going to do preview. So this is now to prepare the geometry for AI. And then here we're just gonna do, maybe we're just gonna give it an offset, slight offset of 0.1. Just sits. And here we're gonna give it a color. We're gonna give it a color of maybe like this, so it just reads a bit better because it's gonna be from quite far. So just need to make sure we can read it. Here I'm just gonna do the same, Control C, Control V, and there. Yeah, I'm gonna give it the same offset. And then for the slab, we are going to give it maybe a darker. dark color. There we go. So I think that looks quite good. So again, you know, we can adjust that a bit. See how it looks like. Okay. And so when we have that, now what we want to do is we want to do our shot. So I'm just here, prepare view, but you can do any view you want, really. So you just place the camera, change the perspective view. Here you can go here and maybe do a 2-point perspective. That was nice. Okay, and then here 50 lens. Just gonna do 35 to see how it looks like. All right, so we are now in ComfyUI. So we have ComfyUI open. I'm just gonna take some space here and Grasshopper. We can almost reduce it, to be honest, but let's keep it for now. Just want to change a bit that color to something a bit more. Hopefully it's contrasty enough. So you need to have a bit of contrast for it to work well. Let's keep it like this for now. Okay, so this is the script I prepare for ComfyUI. So it's pretty much the same as the one I always use. I think I just found it quite funny to try it on the pavilion in the previous video, try it in Paris and see how robust it is, or like if that's just, you know, there's some stuff. And so far it works okay. But for this one, the results were a bit mixed, so it might mean that I need to think about another workflow for this one. We'll see how it turned out for this part. So surprise, I'm doing it with you. So we're gonna figure out how it works. And now I'm setting the area, same idea. Again, I'm using the web version. In case you haven't noticed, because I want to use the screen share. So let me just do it again. I don't want the perspective. There we go. So maybe we're gonna push it a bit. Yeah. The Grasshopper is doesn't like it. I might just reduce it now. And I'll set a new area. Okay. Nice. All right. So same idea for this one. You know, like same size, 1344. Same flags. Same depth. Anything. Canny. So I'm using Canny and depth. And all what I've done when I was preparing this video is I just had a look a bit at the strength. So here I put 0.4 for Canny, and I didn't change the threshold at all, 0.4, 0.8. But again, I was testing on another geometry, so it might not show as well. And this one, 0.60. So let's have a look at it. And then my conditioning is 3.5. And then one thing that I changed though quite a lot and I focused on is my prompt. So of course it's not a pavilion anymore, and of course it's not in Paris anymore. So this one is sort of raw photo, cinematic, street level view of a twisting timber tower, because the previous one I had was twisted. So maybe a timber tower. When reflective glass, front elevation. Yeah, that's not really a front elevation, so just gonna remove this part. Architecture photography. Capture the tower rising. I don't like the word modern. I find it just reminds me of Corbusier always when I heard modern. It's just anyway. It's just it's contemporary, contemporary, but it's not modern. But anyway, soft sunset, reflecting on super reflective glass. 2 times super reflective glass. We'll see. Intrigued timber detailing. Yeah, why not? Elegance, natural material. So for your little information, I asked ChatGPT and I wrote like that's what I want, and to shape me a prompt. It didn't do a really good job, so I just basically copy my previous script, my previous prompt, and say format it this way, because you're not doing such a good job. And he's done this, and this is not too bad. So let's have a look at what's happening here. So again, I resized it. So, you know, I'm going from that format and then it crop it to a vertical format out of this shape. So that's why it's slightly cropped, and it's actually not bad because then it focuses on the tower here, and the framing is not bad at all. All right, so this is the result. The tower is not bad, bit boring, and then the rest, the context is quite boring actually. So this took 46 seconds. Yeah, not fully convinced of those ones. Okay, so this is slightly better. I'm not too sure what it's doing here, but that's quite interesting. There's a bit of reflection. We see the slab. There is somehow the capture a bit of the facade, and yeah, I think it's quite interesting. So maybe boosting a bit the guidance helped a bit through the process. So let's have a look again and do another one. So I think this one came out quite okay. There's some interesting feature in there. One of the things that, so I think it might be from the view. So that's why I'm just trying to set up the view in different ways. So maybe we can just try something a bit different just to see how it looks like. Okay, so I try something different with perspective 3, a bit further away, but there's no building at the base, so maybe that could be interesting. Those ones came up really bad, so we'll see with this one. So it's gonna be this sort of framing, which is quite nice. So we'll see how it comes out. No, not convincing. Not convinced. So I went back to this design here, and then we changed a bit of the pattern because it wasn't quite working, and I update the prompt a bit with something a bit more skyscraper to describe it a bit more like the scale, because I found it didn't really get the scale. High rise, and then I'm talking about reflective glass, small rectangular steel structure, and timber cladding. And I also have added a LoRA, which is the LoRA I trained. And it's algorithm architecture 1.0, which is AA 1.0, which is this one here. And this is the result. So it's actually quite interesting. I think the panel, the facade itself got the scale quite nicely, I'm not super convinced of what's happening here at the bottom. It just didn't pick up some of the things. But I find it quite interesting, this lab, the openings. It's some interesting stuff. So let's run it again. The canny capture the elements quite well. So let's try again and see if what result we get. But I think we're getting close. Okay, this one didn't work quite well. I don't know why it just landed this building there just in front of it. Which, okay, whatever, there's nothing here. And then the pattern somehow got a bit mixed up. But I like those elements here. I think there's some interesting. And then I don't know what that is, but yeah, I mean, it's again some inspiration. Maybe we can bump up a bit our canny. Give it a 0.6 and 0.4, and let's run it again. Okay, ooh, big vignettes here on this photo. Interesting. Okay, different different timber, color of timber, some completely open. Still have the slab edge popping up, so it's somehow like this, you know, like in this geometry I was just doing an offset of those elements, so it's not quite correct in terms of depth, but I actually like that. I like the fact that he picked up on that. Yeah, interesting result overall. I'm pretty happy with this one actually. I think it's a good starting point for discussion again, but I think it's quite good. Let's try the last one. Okay, so yeah, I think there is some timber, there's some glass, sunset is captured there. I think some of the elements, I mean, this is not part of the image obviously, so it's just this part. So I guess, yeah, I guess it's quite interesting. I mean, I like the fact that they really got the scale now right, and I think the pattern here in Grasshopper helps a lot with this to get the scale right, because otherwise it just doesn't get it with the large diamonds. Okay, cool. Thanks for watching. I hope you found this exploration of optimizing coastal tower design with an AI-driven workflow insightful and inspiring. Using Galapagos and generative design can be quite interesting, but it's not only that. There's a lot of different tools out there that we can use to optimize workflow. Multi-objective tools could also be something that we will probably talk about in the next video. And then the workflow we demonstrate today using sort of this geometry and this computational design also triggers some good ideas, some bad ideas, and it's just a good starting point for discussion within the team. Again, it's not meant to be like the final output, but just sort of a starting point for communication and collaboration. And then, yeah, stay tuned on this channel, hit the button, subscribe, so you can just get on top of the new video. I'll be releasing more video. There's one coming up quite interesting with Revit as well, so I try to do a bit of all of different tool we use as architect. But more specifically, if you would like to collaborate with AI and also with computational design within your team, just feel free to reach out. And then all the files are also available on Patreon, and join the community on Discord for free. It's always a nice place where you can just exchange idea, put stuff out there, questions and things like that that could be helpful for you, but also for other. And then, yeah, I think it's just thanks for watching. See you next time.